Hello, everyone, and welcome to Unit 4, Lesson 1, which is going to be about interpreting the meaning of the derivative in context. Now, this is actually going to be a review lesson, and we are going to be kind of reviewing how we interpret the meaning of a derivative. So we have 3 learning targets today. The first learning target is I can interpret the derivative of a function as the instantaneous rate of change with respect to its independent variable. So, with respect to whatever the variable is in the function. The second learning target for today is I can express information about rates of change. So, that's going to be about derivatives in an applied context, so within a story using a derivative. And the last learning target for today is I can use correct units when describing a derivative. Now, it's really important to realize that we have done this before, and this is kind of a review of that information. So right now, I'd like to review with you that whenever we are interpreting the meaning of a derivative, we use I call it like in a nutshell, we use something called NUT. N stands for we need a noun as part of our interpretation. U stands for we need units as part of our interpretation. And T stands for we need a time as part of our interpretation. Now, whenever you're interpreting a derivative, because you're finding a slope, you're always going to interpret it as the rate of change. So you should be looking for or using the words rate of change in your answer. So, for example, you might say if your function is giving you the temperature of an object, that the derivative is telling you the rate of change of the temperature of that object. Now, your units are going to be you're going to need to divide the given units in order to figure out the units for your derivative. Your units should be a fraction because you're finding a rate. So an example of rate units would be like meters per second, or feet per hour, or degrees Celsius per minute. So we're looking at rates. So you're going to divide the output rate divided by the input rate. The output units divided by the input units, and that's going to give you the units for your derivative. And then last but not least, you're going to need a time. Now, since a derivative is the rate at a specific moment in time, it's the slope at one point, we're going to be looking at t equals a specific value. So it's not going to be over an interval like from 0 to 2 minutes. It's going to be at 2 minutes. So you're going to be using the words like at t equals something. Now, I want to make sure that we note that when you find a derivative, if the derivative is positive, then the stuff that you're measuring is increasing. And if your derivative is negative, then the stuff that you're measuring is decreasing. So if the rate of change of our temperature is positive, then the temperature is increasing. And if the rate of change of our temperature is negative, then the temperature is decreasing. Now, we also need to make sure we're using correct notation. So for a function whose derivative is f prime of x, we can show that we found the value of the derivative at x equals 3 by writing f prime of 3. So you're going to have that specific number plugged in there, not just saying f prime of x, but like specifically at the value 3 is what you're finding. The other thing is that for a function whose derivative is dy over dx, we can show that we found the value when x equals 3 by writing dy over dx evaluated at. So you're going to draw this vertical line to show that you're evaluating it at. That's like a shortcut way of saying that. And then you're going to put the number you're plugging in at the bottom, x equals 3. It's really important that you use the right notation when you're explaining your reasoning or interpreting your answer. So suppose V of t represents the volume of water in a tank in gallons at t minutes. Interpret the meaning of the following information in the context of the problem. So let's say that we know dV over dt. That's going to be the derivative or the rate of change of the volume evaluated at t equals 3 is equal to negative 2. So if we wanted to interpret this, we would say dV over dt evaluated at t equals 3. So dv over dt evaluated at t equals 3 gives the, and here's where we're going to use our noun, the rate of change of, in this case, since we were originally finding the volume of the water in a tank, it's the rate of change of the volume of water in the tank. So that's our noun. That's the rate of change of the volume of water in the tank. Now we need our units. So we're going to say measured in this case, it's telling me we're measuring our volume in gallons, and T is going to stand for minutes. So if we divide those units, it would be gallons per minute. So if you divide, you get gallons per minute. And then we need a time. It is telling me here specifically, we're looking at what's happening when T equals 3. So we're going to say at T equals 3 minutes. So we've got our noun, we've got our units, and we've got our time. Now the second part of this is, so what does it mean if we actually get the number -2? So we would say, since dv over dt evaluated at t equals 3 is equal to -2, the amount of water, so the volume of water, in the tank is decreasing at a rate of 2 gallons per minute at t equals 3 minutes. So specifically, this -2 is telling me that my volume is decreasing at that rate at this specific time. Let's try one more. So it says on a certain workday, the rate in tons per hour at which unprocessed gravel arrives at the gravel processing plant is modeled by G of T, where T is measured in hours after the plant opens. Explain the meaning of the following. G prime of 5 equals 38. Now, I'm going to start by saying G prime of 5 gives, since I'm finding a derivative, I'm going to say the rate of change of, and in this case, if we look at what we were measuring originally, G of T represents the rate at which unprocessed gravel arrives at the gravel processing plant. So this was already a rate function, and we took the derivative, which means we're kind of looking at like the second derivative here. It's the rate of the rate. So this is going to give us the rate of change of the rate that we already had at which unprocessed gravel arrives at a gravel processing plant. So it's the rate of change of the rates at which the unprocessed gravel arrives at the gravel processing plant. Now let's talk about our units. So measured in, now it was already tons per hour, and T is measured in hours. So if we divide those things, it's going to be tons per hour divided by hours again would be another per hour. Or sometimes like in physics, you might see this as written as like tons per hour squared. You're dividing by tons per hour again. And then we have to look at the specific moment in time. So the moment in time here is at t equals 5 hours. Now, in this case, since we had a positive number here, we can say that since g prime of 5 is equal to 38, the rate at which unprocessed gravel arrives so the thing we were measuring, the rate at which unprocessed gravel arrives, is increasing because that's a positive number at a rate of 38 tons per hour, and then another per hour because it's like the second derivative. We're finding the slope of the slope at t equals 5 hours. So what that's basically saying is, like, if you know how fast your gravel's arriving, it's coming faster and faster and faster. So like if you got 10 tons in the first hour, then you're going to get 20 tons per hour in the second hour. So it's going to arrive faster and faster and faster and faster. Now, the last thing that we're going to be talking about is finding derivatives on a calculator. Now, this is something we haven't done before. A big focus of the first few units of this class are how we find derivatives and all these derivative rules, but your calculator can also do this for you. So we have learned many, many derivative rules throughout this year so far. We can also use our calculator to find a derivative, and I'm going to show you how to do that now. So on your graphing calculator, there is a menu on the left-hand side that says math, and that's going to be like a menu where you can find lots and lots of cool functions your calculator can do for you. If you open the math menu and you scroll down to option 8, you'll see it says N derive. Now, that's short for derivative, and the N is short for numerical derivative. What this means is that you can find a derivative on your calculator, but it will only find you the derivative at a specific value. It's not going to ever give you like an equation for a derivative, but it will give you the value of the derivative at a specific number. So, as a reminder, so that you have it written down, if you want to use your calculator to find a derivative, the two buttons you need to push are math and then option 8. And you can actually push the number 8 instead of scrolling down to find that option, or you can scroll down every time to find that option. So let's try this problem. It says when a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display table at a rate modeled by this function, where f of t is measured in pounds per hour, and t is the number of hours after the store opened. First, we're going to try to find f prime of 7. So our first step here is going to be to find f prime of 7. And we're going to do that on our calculator. After we find f prime of 7, it says use correct units to explain the meaning of f prime of 7 in the context of the problem. So the first thing I'm going to do here is just find this value. So f prime of 7 equals. Now, in order to do that, I'm going to go on my calculator, and here's what I'm going to do. I'm going to go to math, and I'm going to literally just hit the number 8. You can see I'm just going to tap this number, and it pulls up this kind of formula that you're going to plug stuff in. So you're going to type in d over, now the symbol for derivative is d over dx, so you need to put an x in that box. You can see that this button right here has x, t, theta, n. That's kind of like your variable button. If you just hit that button, it puts an x in there for you. Now, inside the parentheses, we're going to type in the function that we're trying to find the derivative of. So I'm going to type in 10 plus parentheses 0.8. Instead of t, I'm going to put x, because on my calculator, that's the variable I'm going to use. And then sine of, I'm going to have x to the third power and then divided by 100, and I'm going to close that parentheses. Now, real quick, I'm just going to make sure I'm in radian mode. If you go to mode, you can make sure you're in radian mode. You need to be in radian mode for all of your math problems for calculus. So you'll see that I typed in my function, and since I want to know the derivative specifically when x is 7, I can see that 7 is the number I'm plugging in. You can see that it's got that line that we used to mean evaluated at, and we're going to say x equals 7 and hit enter, and it's going to just tell me my answer. Negative 8.119539823. In calculus, you are going to truncate, which means just stop after the third number. You don't have to round. You don't even have to look at the fourth number. You're just going to copy down the first 3 numbers after the decimal place. Okay. Now, after you found the derivative, we want to interpret this. So, if we go back to what it means to interpret, we're going to need a noun, we're going to need units, and we're going to need time. So we're going to say f prime of 7 gives. Now, since we found a derivative, we're going to use the words the rate of change of the function that you had. Now, the function that I have is telling me that this is the customers remove bananas from the display table at a rate modeled by this function. So this is the rate that customers are removing bananas. So I'm going to say the rate of change of the rate at which customers remove bananas and then we're going to need units. Now this unit is already in pounds per hour, and T is the number of hours. So when we divide those things, we're going to say it's pounds per hour, so measured in pounds per hour. And then we need a time. Now the time here is going to be 7. So we're going to say at T equals 7 hours. Now the second part of this is to kind of explain what this specific value tells us. The negative 8.119 is going to tell us that the thing that we were measuring is decreasing because it's negative. So we would say since f prime of 7 is equal to negative 8.119, we would say the thing we were measuring, so the rate at which customers remove bananas, is decreasing because it's negative. And then we would say at a rate of 8.119 pounds per hour at T equals 8 hours. All right, that is it for today. Thank everybody so much for watching. I really appreciate it, and I'll see you soon for some practice.